Load calculation software is essential for accurately determining the heating and cooling loads of a building. Some software options not only provide the final answer but also show the detailed calculations involved, which is incredibly valuable for ensuring accuracy, transparency, and understanding the process. Several key features distinguish effective load calculation software. Firstly, detailed calculations are crucial, displaying all the computations and assumptions made for each load. This includes variables such as building size, orientation, usage, and climate data. Secondly, a step-by-step analysis walks you through each stage of the load calculation process. This makes it easier to understand the methodology and identify any potential errors. Thirdly, comprehensive reports generate professional-looking documents that include all the calculations, assumptions, and results, ensuring transparency and accountability. There are several recommended software programs that offer these detailed calculation capabilities. One option is Carrier HAP, a commercial software program that provides extensive load calculations and thorough reporting. Trane Trace 700 is another user-friendly software designed for load calculations and system design for both residential and commercial buildings. Revit MEP is a powerful software suite that integrates load calculation features within a 3D building model. IESV is a leading energy simulation software that offers detailed load calculations for various building types and energy systems. eQuest is an open-source software that allows users to perform comprehensive load calculations and energy modeling. The advantages of using software that shows detailed calculations are numerous. One significant benefit is improved accuracy and reliability. By displaying the step-by-step process, these software programs help ensure that the load calculations are accurate and reliable. Another advantage is enhanced transparency and auditability. The detailed calculations allow stakeholders to review and verify the assumptions and methodology used, promoting transparency and making the process auditable. Load calculation software serves as a valuable educational tool, helping users understand the principles and techniques involved in load calculations. The step-by-step process makes it easier to identify and correct any errors that may have been made during the calculations. Finally, detailed load calculations provide engineers and designers with a solid foundation for making informed decisions about heating, ventilation, and air conditioning system design and operation. When choosing load calculation software, look for programs that offer detailed calculations, step-by-step analysis, and comprehensive reporting. This will help you ensure accuracy, transparency, and a better understanding of the load calculation process. Detailed calculation software helps to ensure the accuracy and reliability of the results. This is because each step of the calculation is visible, allowing you to verify the inputs, assumptions, and formulas used. This transparency helps to minimize errors and provides confidence in the final load estimates. Detailed calculation software allows for transparency and auditability of the load calculation process. Stakeholders, such as building owners, architects, and contractors, can review the calculations to understand the basis for the load estimates. This transparency fosters trust and facilitates collaboration among project team members. Detailed calculation software provides an educational opportunity for users to learn about the principles and techniques of load calculations. By seeing the step-by-step process, users can gain a better understanding of how different factors influence heating and cooling loads. This educational value is especially beneficial for students, interns, and entry-level engineers. Detailed calculation software makes it easier to identify and correct errors in the load calculation process. If the final load estimates seem unreasonable, you can review the calculations to pinpoint the source of the error. This can save time and money by preventing costly mistakes in the design and construction of the heating, ventilation, and air conditioning system. Detailed load calculations provide engineers and designers with a solid foundation for making informed decisions about heating, ventilation, and air conditioning system design and operation. With accurate load estimates, they can select the appropriate equipment, size the ductwork, and optimize the system for energy efficiency and occupant comfort. Commercial software like Carrier HAP offers comprehensive features for detailed load calculations, including weather data integration, building modeling capabilities, and automated reporting. It is suitable for complex projects and large commercial buildings. Trane Trace 700 is a user-friendly software popular among heating, ventilation, and air conditioning engineers and designers. It provides intuitive tools for creating building models, defining thermal zones, and performing load calculations. Revit MEP is a building information modeling software that includes integrated load calculation capabilities. It allows you to perform load calculations directly within the 3D building model, streamlining the design process and improving coordination among disciplines. IESV is a leading energy simulation software that offers advanced features for detailed load calculations and energy analysis. It can simulate the performance of various building systems and evaluate the impact of different design options on energy consumption. eCrest is a free, open-source software that provides a comprehensive set of tools for load calculations and energy modeling. It is widely used in research and education and is suitable for a variety of building types and applications. When selecting load calculation software, consider the following factors. Firstly, the level of detail required for your projects. Some software programs offer more detailed calculations and features than others. Secondly, your budget. Commercial software programs typically require a license fee, while open-source software is free to use. Thirdly, your level of experience with load calculations. Some software programs are more user-friendly than others. Fourthly, the compatibility of the software with your existing design tools and workflows. Fifthly, the availability of technical support and training resources. Load calculation software that shows the detailed calculations can be a valuable asset for heating, ventilation, and air conditioning engineers and designers. It helps to ensure accuracy, transparency, and auditability of the load calculation process, provides an educational opportunity for users, and facilitates informed decision-making about heating, ventilation, and air conditioning system design and operation. Whether you choose a commercial software program or an open-source option, be sure to select software that meets your specific needs and requirements. Detailed load calculations are the foundation for efficient and effective heating, ventilation, and air conditioning system design. By using software that shows the calculations, you can ensure that your designs are accurate, reliable, and optimized for energy efficiency and occupant comfort. Building orientation affects solar heat gain through windows and walls. Software takes into account the direction a building faces when calculating heating and cooling loads. Building materials affect heat transfer through walls, roofs, and floors. Software incorporates the thermal properties of different materials to estimate heat gain and heat loss. Window characteristics such as glazing type and shading coefficients affect solar heat gain and heat loss. Software allows you to specify window properties for accurate load calculations. Infiltration refers to the leakage of air into and out of a building. Software estimates infiltration rates based on building construction and weather conditions. Ventilation is the intentional introduction of outdoor air into a building. Software accounts for ventilation rates to ensure adequate indoor air quality. Occupancy levels affect internal heat gains from people, equipment, and lighting. Software allows you to specify occupancy schedules and heat generation rates. Lighting levels affect internal heat gains from lighting fixtures. Software incorporates lighting power densities and operating schedules. Equipment loads affect internal heat gains from appliances, machinery, and other equipment. Software allows you to specify equipment power consumption and operating schedules. Climate data such as temperature, humidity, and solar radiation significantly affects heating and cooling loads. Software integrates weather data from various sources to perform accurate load calculations. The software calculates heat transfer through walls, roofs, floors, windows, and doors based on their thermal properties and temperature differences. It estimates solar heat gain through windows and walls based on orientation, shading, and glazing properties. It determines internal heat gains from people, lighting, equipment, and appliances based on occupancy schedules and power consumption. It accounts for infiltration and ventilation rates to estimate heat loss and heat gain due to air leakage and outdoor air introduction. It calculates heating and cooling loads based on the building's thermal characteristics, internal heat gains, and climate data. The software generates reports that summarize the load calculations, including peak heating and cooling loads, energy consumption estimates, and equipment sizing recommendations. The software provides detailed information about each step of the load calculation process, allowing you to understand the assumptions and methodologies used. The software allows you to customize various parameters such as building dimensions, material properties, occupancy schedules, and climate data to suit your specific project requirements. The software integrates with other building design tools such as computer-aided design and building information modeling software to streamline the design process. The software includes built-in error checking and validation features to help you identify and correct any mistakes in the load calculations. Carrier HAP, Trane Trace 700, Revit MEP, Wise V, and eQuest offer features that can assist in detailed load calculations. Building load calculations determine the required size of heating and cooling equipment. Load calculations are essential for designing energy-efficient buildings. Accurate load calculations prevent oversizing or undersizing of HVAC systems. Load calculation software simplifies the complex process of manual calculations. Software can model various building configurations and orientations. Different types of software cater to residential or commercial buildings. Detailed calculations help identify areas for energy savings in a building. Software reports provide insights for optimizing building design. Load calculations are often required for building code compliance. Accurate load calculations contribute to occupant comfort and satisfaction. Software can simulate the impact of different building materials on loads. Load calculations consider factors such as insulation levels and window types. Professionals use software to perform load calculations efficiently. Consistent and reliable results are achieved through software automation. Software can integrate weather data to perform accurate calculations. Software updates ensure compliance with the latest industry standards. Load calculations are important for sustainable building design practices.